Shells, subshells, and orbitals. These help us understand where electrons are on the atom. And if you haven't watched the video on the structure of the atom, you'll want to start by going there first and watching that, and then come back and take a look at this one. So, shells, subshells, and orbitals are kind of these fancy terms for where an electron lives. So you can think about it, and I've got this imaginary letter that someone has addressed. Well, it's an actual letter, it's not imaginary. But somebody has addressed it to Santa Claus. And you can see that there's a P.O. box there, and then it's at the North Pole in Alaska. So an address has some specific information so that when the mailman gets all of these letters, they can sort them first according to the country, which is the biggest, or excuse me, not the country, the state, which is the biggest, and then the city, and then finally the very specific and precise location of where your house is. So in terms of an electron, the shell is kind of like the state. It's large, and it has a lot of people living in it. So in our metaphor, shells have lots of electrons. So they're sort of the broad category. So this is a large category with lots of electrons. The subshell exists within the shell, just like a city exists within a state. And a subshell is going to be a little bit smaller, and it's going to contain, so it's kind of like a city, and it will contain some orbitals, and it exists within a shell and contains orbitals. Orbitals are like your house, right? Now we're getting pretty precise. There's only a certain number of people who live in your house versus the number of people who live in the state of Alaska, assuming you lived in Alaska. So the orbital is kind of like your house number. Now we're getting very specific about where the electrons are, and in fact, there's only 2 electrons allowed in each orbital. So when we get down to talking about a specific orbital, we're talking about potentially just 2 electrons. So when we look at where an electron is, we need to know what shell is it in, what subshell is it in, and often what orbital it is also in. So let's talk more about what shell, subshell, and orbital look like and mean on the atom. So the shell is a region of space around the nucleus that contains electrons of approximately the same energy. You can see from this picture here that if we think about the nucleus as being in the middle, this is the Bohr model of the atom, then the shells are these rings that move around the outside. And in fact, shells are denoted using numbers. They have numbers. So if we talk about shell number 1, we're talking about a shell that's very close to the nucleus. Versus shell number 5, well, that's a ways out from the nucleus. And what we want to remember here is that the nucleus is a big ball of positive charge, right? It's just a lot of positives. And electrons are negative. And they really want to be close to the nucleus. So if you're in shell number 1, hey, that's a pretty sweet spot for an electron. Versus shell number 5, you're pretty far away from the nucleus. All right, within those shells, there are subshells, and they are a region of space within the shell that contains electrons of the same energy. So a shell can have multiple subshells. Can contain, depending on which shell we're talking about, can contain multiple types of subshell. Subshells can contain multiple amounts of orbitals, and we'll talk about that here just in a minute. But let's take a picture, let's look at a picture of what subshells generally look like. So there's 4 types that we'll discuss in this class. There is the S subshell, and in this picture they've labeled them as orbitals because the subshell is sort of the shape, and then the orbital is the specific thing that we're talking about. So we have the S subshell, oops, I'm ahead of myself. The S subshell, which is spherical shaped. That's a sphere. We have the P subshell, which is kind of this dumbbell or infinity shape. And then the D subshell, it gets a lot more complex with D, and then finally with F. I would expect you to be familiar with the idea that the S subshell is a sphere and that the P subshell is this infinity symbol type shape, about your electrons as living in that space. So the thing also to recognize here is that these shells and subshells are coming out of quantum mechanics. And the quantum mechanic principle at the base of it tells us that electrons, we can't know exactly where they're at. So the subshell, these shapes that we've got here, they're pretty much telling us where we think the electron is most likely to be. So it's talking about a probability of their location. We don't know that they're exactly right there, but we can say in this region of space, this is most likely where the electron is located. So let's talk a little bit more about orbitals. Like I said, they can contain 2 electrons. Those electrons are at the same energy and they have opposite spin. Spin is a quantum mechanical property. We won't talk a whole lot about it other than to say that it allows us to distinguish between electrons in a particular orbital. The type of your subshell is going to determine how many orbitals are present. So if I have an S subshells only have 1 orbital. Since 1 orbital contains 2 electrons, then I have only 2 electrons in an S subshell. A P subshell can contain, in fact, will contain 3 orbitals, which means it could contain 6 electrons. A D subshell contains 5 orbitals and 10 electrons, and my F subshell contains 7 orbitals and 14 electrons. And if you are having trouble remembering this, just remember 1, 3, 5, 7. S, P, D, F. SPDF. Okay, the periodic table is really helpful when it comes to knowing where electrons are, because it is actually organized with some chunks that tell us something about shells and subshells. So it turns out that your shell number on the periodic table is going to correlate to the row number. So if I mentioned that I want to talk about an element or an electron that's in shell number 3, then I would be looking at the 3rd row in general. We'll talk about the exception to that here in just a sec. Subshells are correlate to the columns of the periodic table. I spelled columns wrong. And this periodic table is color-coded, and you can see this section, which is purple. It also includes helium over here. It's kind of stinky. Helium's hanging out over there with the noble gases. This is the S subshell region. This pink box of 10 boxes in a line is the D subshell. The blue at the very end of 6 boxes is the P subshell. And located down here, sort of cut out of the periodic table because it would be enormous if we didn't have it cut down here, is the F subshell. So if I asked you where the 4P subshell was located, you would check this number and this letter. And this number, you would say, oh, I need to find the 4th row, and I need to find the P block. So we would count 1, 2, 3, 4, and here's the P block. So it would be one of those elements. I just realized for some reason my periodic table is missing some G's. G-A and G-E, right there. Okay, so the D subshell is a little bit tricky because everybody else, their row number equals their shell number. But in the D subshell, what we find is that the shell number equals the row number minus 1. So if we are looking for the, let's say, 4D subshell, we would actually go to the 5th row. because 5 minus 1 is 4, and so the shell number would be 4d. Okay, let's try some examples. Which element has 1 electron in the 3p subshell? So I need to find the third row and the p block, and 1 electron tells me I'm looking at 1 box on the periodic table. 1 box equals 1 electron. So let's go, no, I didn't do another periodic table. Go back to my periodic table, which is kind of messy. I'm looking for 1 electron in the 3p's. So here is the third row. 1 electron is 1 box, and wow, my periodic table is missing a letter. That's aluminum. So aluminum would be the electron that has 1 electron in the 3p. At which element is the 4s subshell half full? So let's find the 4 s's. And I'm going to erase here a little bit so we can clean this up so it's not confusing or distracting to you. Oh, I wrote a lot. Okay, let's get rid of that too. All right, we're looking for the 4s. So we find the 4th row. The s block is right here. Now, I see that there's 2 boxes there, so there's 2 electrons. Half full would be 2 divided by 2, which is 1. So in specifics, we're talking about potassium. Which element starts the 4d subshell? Well, if we're looking at the 4d subshell, then we must be looking at the 5th row, because it would be 4d would be 5 minus 1. And so that would be the 5th row. Here's the D block, and there's the first element, which is yttrium. And last, which element contains a half-full second shell? This one's a little trickier because we have to think of who has number 2 out front. Well, we have the 2s, and we also have the 2p's. The 2s has 1 orbital and can take 2 electrons, so there's 2 electrons in there. And the 2p subshell can take 6 electrons, so there's 6 electrons in there. So there's a grand total of 8 electrons. Half full would be 4 electrons. So that means I would have 2 electrons in the 2s, and then 2 more electrons in the 2p. So basically, to answer this question, I have to find an element that has 2 electrons in the 2p subshell. So I'll go back here. The 2p's are in the 2nd row, and I see that that would be 2 boxes in, which would be carbon.